So I'm going to talk about a tool that we began back in 2012, and it consists of a carbon calculator, library of case studies, and information sheets, and we'll go over that. This is my contact information, and if anyone has interest in following up, please feel free to reach out to me. So first, I just wanted to talk very briefly about what I do, just in case, I don't know, sometimes when you speak with other professions, people aren't exactly sure, and why what I do led me to creating STiCH. As a conservator of cultural heritage, we work on art, and I like to call it cultural heritage. It's more encompassing, and we fix things. Which is one of our jobs. So this is a Iranian vessel that was from about 2000 BC. It was Princeton University Art Museum. On the left, this is how I got it. And then the curator asked me to take it apart because the joins weren't so great, because it's all in fragments, and the fills weren't so great. Take it apart, put it back together, fill losses, and then make losses disappear with paint. So that's one thing that I do. The materials that we use to do this kind of work are pretty involved. Sometimes when you have to reverse joins in a vessel, it can be, or you have to inject something like a glue or a solvent for any reason. We use syringes. They're sterile syringes. So we use a lot of materials from the medical profession. We use also from the medical profession scalpels and scalpel blades. Those are also sterile, and we often use this blade, this handle, and this blade a lot. And we will use one blade. I can sometimes use it over 20 times, over 50 times, or once, depending on what I'm using it for. We use glues. We use resins a lot that are acrylic resins, so they're petroleum based. They're made from virgin plastic, and then to dissolve them, they come like this. It's called acryloid B72. That's one type, and then there are many other acrylic resins that we use that come like this in these pellets. Then we dissolve them in a solvent. This is probably in acetone and ethanol. People use it in toluene quite a bit. And so we can make it up like this in a jar, or it can come in a tube like this, or we will put it in a tube. So this is just to give you an idea of the materials that we use, and how energy intensive and virgin material intensive they are. Another thing that we do, this is an example of a project that I worked on, a large Louise Nevelson installation, an entire room. And I was removing restoration paint to expose the original paint. And I was using a nano gel. So these are gels made of PVA, made of polyvinyl alcohol. They're flat. They're made of kind of like the material that you use for contact lens. And you can deliver anything from any type of water systems, or isopropanol, because isopropanol is ethanol with a certain percent of water in it. This is an idea of the size of one of the sculptures. So we're taking all of the restoration paint off of this kind of sculpture. You can see the scale of my colleague here, and to expose original paint. And not only did we have to do that, but we had to go all over the entire room. So this was the smallest of the sculptures, and inject a glue. We used a glue made of algae, made of seaweed that was imported from Japan. So we injected that with syringes to set down the paint, the original paint. So again, we're using a lot of materials here. Also, another thing that we do is we pack art for storage and for shipping. So this is packed in archival archival cardboard. So it has its calcium carbonate as a buffer to absorb anything in the atmosphere to keep the materials that are stored in it safe. And then we put things in crates and we ship them all over the world. Another thing that happens a lot is we use a lot of foam products. This is called ethafoam. We use a lot of this to stabilize, to pack things, to cushion them and to absorb vibration. And then it's put in a wooden crate. And yes, this is Tyvek. We use Tyvek a lot to wrap objects. I was trying to pull large things because I thought that there would be architectural preservationists here. This is a piece from the 20th century from New Guinea. It was quite big. Often we're using these foam products in ways that they don't really need to be used. We're using a lot of foam to support a wooden piece as much as to support a stone piece. So we're doing things over and over and over again without really thinking and without really knowing the environmental impact, which is fine if it doesn't have an impact and if we weren't in this climate crisis that we are in. So back in 2008, I became pretty disillusioned with my field in terms of the idea that we're preserving our heritage without really thinking about what we're doing to the environment. And it's this idea that our work is so special and so important, we can't sacrifice what we're doing. We can't not use these sterile needles. We cannot use these sterile syringe, scalpel blades. And everything else we use, forget about our own health, because that's your individual choice. But the health of the planet is quite important, and it just seems this contradiction. And back in 1987, at the World Commission on Environment and Development, Gro Brundtland has this wonderful quote: "Humanity has the ability to make development sustainable to ensure that it meets the needs of the present without compromising the ability of future generations to meet their own needs." And that really just struck home for me, because when we're preserving our heritage, we're only thinking of future generations. So this contradiction is so strong that it made me really begin to look at, how do we change what we're doing? How do we stop thinking in this same way and move on in an educated way? When I would do my work, I would think, okay, I'll use steam instead of acetone. But I didn't know, if I'm using steam, I'm using a lot of energy. Maybe it's worse to be using steam than to be using acetone. Steam's better for my health, but if I'm wearing a respirator and I'm really concerned about the environment, what kind of choices can I make? So how can I become more educated and start solving problems by using different thinking? How can I start thinking differently? So that was when I started researching different ways of looking at environmental impact. And that's when I found out about life cycle assessment. And when I finally got in touch with Matthew Eckelman, who let's see, it's not there yet. Matthew Eckelman, who is the engineer from Northeastern University, who I've been working quite a bit with. He and I started doing this work and started doing case studies back in, our first one was in 2012, and that was published in 2016. And through that, we created STiCH, which is, it's housed on the Foundation for the American Institute for Conservation of Historic and Artistic Works. And that's part of the AIC. So it's FAIC is the foundation, AIC is the organization. It's an organization for conservators, as you may know. And we created this tool so it could be specific to each conservator's work, and to art handlers, exhibition designers, registrars, all across the board. And I'll talk about that some more. So we have a carbon calculator that is an interactive calculator, and it compares items according to CO2 equivalent. So it's the production of the items. We do not yet have transportation or disposal of the items. Then we have case studies. Right now we have 4 case studies, and they are made to explore more complex actions. So the calculator, you would compare acetone to ethanol, or ethafoam to paperboard, or I think we have a whole bunch of different types of woods, many types of woods. So you'll compare one amount to another amount that you'd have to use. The case studies go more in depth. They look at transportation, energy use, disposal, and all types of impact categories, which I'll talk to you not only CO2 equivalent. So the four case studies that we have is one looking at backing boards, which is cardboard, plain cardboard, archival board, and then something called Coroplast, which is a polyethylene board, and then foam core, which I know architects use quite a bit. And then we looked at crates for shipping 3D objects and flat work. We looked at gloves, nitrile, latex, and cotton, really looking at them from the use of the art handler and the conservator. And we also did one looking at an environment, either a low oxygen environment for maintaining oxygen sensitive materials long-term, something like the Declaration of Independence, Articles of Freedom are stored in low oxygen environments, or using that for insect eradication, which is done when a collection's infested. We also have information sheets. I'd encourage you, if you want to know more about life cycle assessment and more about how we made our carbon calculator, to look at our information sheets. This is our team. Matt Eckelman is an associate professor of civil environmental engineering. I've learned so much from him. He does all the LCA work. Sarah Sutton does a lot of work with sustainable development in museums. And then Sarah Sanchez is a PhD candidate under Matt Eckelman, who did all of the calculations. She and I spent hours and hours and hours on Zoom working together on this project. So just in case anyone doesn't know what life cycle assessment is, I'll say very quickly, it's a systems modeling tool for quantifying the total resource inputs and environmental burdens of a particular product classified by impact categories. And there are generally about 8 to 10 impact categories that are looked at when you do a complete LCA. One of these categories is CO2 equivalent. It goes under greenhouse gas emissions and global warming potential. So if we're looking at the life cycle of a newspaper, we look at the material production and the natural resources, the logging, the water, all the energy that might go into it. And then we look at transportation of those materials to the product manufacturing site. So it's creating the paper, rolling the paper, printing the newspaper, and all the energy that's involved in that. You could even start looking at the transportation of the workers to the site, the food that they eat for their energy. It just depends on how far out you want to go, how large your systems study wants to be. And then distributing the paper to the person who's reading it, and how long are they going to read it? Maybe an hour if they're lucky. So you're doing all of this work for something that's used for this amount of time, and then transporting again for recycling and disposal. So you're looking at the energy and the emissions going in, the energy going in, the emissions going out from this whole process. LCA components, first you determine why are you carrying out the study and how are you going to carry out the study. You look at the goal and scope, you define the goal and scope of the project, and then you create an inventory list of everything. So if we're looking at the newspaper, we'll write an inventory list of, say, the logs, say the processing of the paper itself, deacidification of the paper, all of the chemicals that go into making the paper and the water, or you may not want to include that. It depends on what you're studying. And then an assessment. And this is an iterative process, so you're constantly going back and forth and looking and re-evaluating what you're doing. And it's all by the 14044 ISO standard. Categories of impact assessment. So everybody knows about global warming potential for all greenhouse gases, including carbon dioxide, methane, nitrous oxide. And then you can also look at smog potential, so that photochemical smog, nitrogen oxides, volatile VOCs. acidification potential, human toxicity, ozone depletion potential, and eutrophication. So these come in just like you have CO2 equivalent numbers. Each one of these have a type of number that is accessed through modeling your data through using LCA. So I'm going to stop to, let's see, I need to stop sharing my screen. I'm going to take you into our site, into STiCH. So this is STiCH. It's stitch.culturalheritage.org, sustainability tools, sustainability tools and cultural heritage. This is our homepage. It was designed by a Pratt information design student, Varnika Kundu. She did an amazing, amazing job. It was also a lot of work between us because it was so important to have this material represented in a way that people in the cultural heritage sector could relate to, because this is pretty complex data. And then we have explanation of it, and then we have our case studies, carbon calculator, and information sheets. We will be doing an exhibition, but I'm going to show you right now the carbon calculator. So here's our carbon calculator. We have an explanation of it and steps of how to do your calculation. So that there are two ways that you can find a material. Let's see. I think for right now, I will just do solvents. And then in the question and answer, if you have other items we want to look at, you can. And then I know I'll do an organic solvent, select an item, and as we talked about, acetone, and then I add. And then you can see the information comes up here, the categories, the item, the amount, and then the greenhouse gas emissions per unit, and then the total greenhouse gas emissions for 1 milliliter of acetone. Now, say I want to compare it to another solvent. Say I want to compare it to ethanol. So here we have 1 milliliter of acetone compared to 1 milliliter of ethanol. And you can see in this very clear graph that acetone has, it's about double ethanol. But what if when I'm cleaning, I need to use 5 milliliters of ethanol for every 1 milliliter of acetone? Then that switches. So another way we can search is you can search items, you can type them in. But just to show you the items that we have here, you can see wood composites, paints, mediums, foams, supports, fillers. We have a lot of materials for outdoor sculpture cleaning. I'm just trying to think of materials that would relate to this group. Just a word of warning, 30% of the tool is done. This is a grant, and students are doing the work, and it takes time, so it's not complete yet. We're applying for more NEH grants. Just to say about us, this project was funded by FAIC Pratt with their students, Northeastern University, and National Endowment for Humanities. We've had 2 NEH grants, one tier 1 and one tier 2, for a total of $400,000. We're applying for another IMLS grant and another National Endowment for the Humanities grant, hoping to get up to $1 million in funding to expand the tool and to expand the calculator and the case studies. But we don't know if we'll get that. I just want to show you also the case studies. Here we have each one of the case studies that are complete. So one that I want to talk to you about is crates. This one, historical building window assemblies, we have it almost, it's not done, and we have the beginnings of it. So we're going to try and post something about it. Carbon footprint of a museum loan, we published in AIC 2012 Journal of AIC, and you can see a full write-up, and we're going to do a scenario of it here. So once you access this, this is the whole write-up of the case study, and with illustrations and all the references. And I'm going to show you this in some slides and the results. So you can look at this yourself. I'm going to show this to you in a very concise way in my slides. So I'm just going to go back to my slides. Okay. So this is one case study on crates, and again, I'm trying to find things that might relate to your field. We're going to be expanding case studies and expanding the library of case studies, and we'll be working with professionals who will design the case studies. So this case study looks at standard crates that house objects for less than 72 hours, and then it gets thrown out. And the goal of this study was to identify the crate materials and crate types by degree of impact. So we looked at one crate flatwork, that's like paintings, drawings, works on paper. And then what's 3D object crate. And this is called the functional unit, where we're looking at this size crate and this size crate. These crates are also come in reusable crates, which I'll show you. These do not. So these are the crates. This is a single trip crate. You can see there's not much foam in here, and it gets used. Goes to the museum and gets thrown out. This is round trip, so it goes to the museum and then back to the owner. It has more foam, and then this is called a museum crate, where it has this extra rain cap and is a little bit more sturdy. And then these are the reusable crates. All of these crates, single trip, round trip, 1 and 2, all have wooden shells. The reusable is made of epoxy resin and glass fiber, so the shell is much harder, and it's used 200 times. So these are the 4 scenarios. The functional unit is this size flat work for crates and this size for 3D objects. And then this is what each one is made of. These are the results. The single trip, you could see the flat work crate, because it's used so many more times. The flat work crate, sorry about this, the flat work crate versus the 3D crate, single use here, compared to the round trip. So the more times you use it, the lower the lower the impact. But here you have the round trip type 1 and type 2. It kind of contradicts that, because it has so much more material, so much more foam, and so much more plywood, wood components. So even though we're saying if you use it more times, it has lower impact, you really have to do this study. And then here's the reusable crate, which because even though you'd think epoxy resin and fiberglass would have a higher impact than wood, here, because it's used so many more times, 200 trips opposed to 1 trip or 2 trips, the impact is so much less. And this is a little bit more detail. We looked at the foam. So if you think of foam like what mattresses are made of, and then or foam core, or any product that has a blowing agent that's combined with a petroleum base to create a chemical reaction for a closed cell product, it's a high, it emits either CO2 or nitrogen. They used to use chlorofluorocarbons and hydrofluorocarbons, which are high ozone depleting materials. So here you have the interior. This is a more dense product, and this is a less dense product. So it just shows a breakdown from disposal, transportation, exterior, and wrapping, interior and wrapping. And what we wanted to do with this study was to compare these foams to a different type of foam, a different type of material. So we were looking at mycelium foams, but these foams the mycelium foam it off gases so much that the contact with the art object is problematic. Now, this is where conservators really need to start re-examining our standards, because yes, for a metal object that is highly corrosive, that is highly reactive with its environment, you wouldn't want to use this. But for a stable ceramic vessel or for a stable stone vessel for 72 hours, and the amount of impact that you're reducing is so great, we have to review these standards. So a lot of times I have colleagues say, you know, our work is so insignificant and our work is so important that we don't have to change what we do. And this is so against the whole movement in the climate crisis, where messaging of cultural heritage, including cultural heritage, is so inspirational, and it gets to so many people. If a museum is showing that they're working sustainably in this type of way, how much energy they're saving, what types of practices that they're doing that are lower impact, and if they're showing they're doing LCA, so they know this, it's not just out of instinct, it's out of real quantitative analysis. And often LCA has surprises. I mean, we didn't know that the foam would be so high. We didn't know that the 200 times used crates would have such a lower impact. And as a result, now we have crating companies that are really exploring these reusable crates and really doing a lot of work with us, exploring different products for vibration absorption and cushioning. So LCA is one of many tools that empower us to make effective changes, and STiCH is one way. There are many others. We're trying to lead by example and use the public face of cultural heritage to really begin to make a change. Something that we're not going to do breakouts, but this is just something that I think is some questions that are really important. Matt Eckelman came up with these that I think are really important. What do you, and something that I think that we should all think about, because sometimes we know that this is right, but we don't have real points that we can then start working towards. What do you see as the most pressing environmental challenges in your work? What scenarios or comparisons are you most curious to explore for LCA case studies? What environmental issues are important to you? Is it, the water? Is it air? Waste? What other criteria are critical in your decision-making process? How do you make these decisions? And what affects you in your decisions? Human health? For conservators, often we think about our health in terms of everything that we're getting exposed to. One thing we have to be careful of is this slant that we let industry get away with so much. For example, British Petroleum, they branded the idea of the carbon footprint. They coined the term carbon footprint to blame us for our greed, and then to make them look like they're more sustainable, which they're not, and to kind of take it kind of greenwashes and takes the onus off of them and puts it on us. So, ride your bike to work, but what are they doing? Rebecca Solnit wrote a wonderful a really fascinating article on this, and she quotes, and this is a quote from the article where Bill McKibben, who really promotes a lot of movements and democracy in terms of changing, that we really have to work on the government, which is so true, and on industry. But then Rebecca says, but individual and collective action don't have to be pitted against each other, and our individual choices add up. So then if we're using a tool like STiCH and we're constantly thinking about this, then the next person is, and the next person is, and then that what puts pressure on industry to make a change. So there are different routes to do this, and all of the routes are important. Our next steps, we're continuing, we're just finishing up this final NEH grant. It's finished in the end of December. We're hopefully have an exhibition on our online, beginning of an online exhibition will be added before we stop our work. And we're also looking at international collaborations. There's been a lot, we've had, especially when I was in Rome, there's a lot of interest in including materials and actions from around the world. Our work was all done based on actions and materials from the United States because it was an NEH grant, a United States government grant. We're looking at teaming up with engineers in Venice, conservation scientists in Florence. I'll be in Cambodia working with conservators and a lot of museum people discussing this as well. These are all the people involved in the project. As you can see, designing the case studies really required a lot of conservation professionals. We tried to include not only conservators, and that's what the NEH grant, our next grants will do. So it was just, and a lot of conservation students were involved as well. And so we're trying to expand this more, and engineering students. So. And again, these are the funding and participating institutions. Thank you so much for your time and for your interest in this material, and I hope that you tell everybody about it.